Hello everyone and welcome back to another video. In this video we are going to see how to pass through a GPU to a Proxmox VM. But what is GPU pass-through? So GPU pass-through is the process of getting the GPU present on the host system to the virtual machine as if it was physically present in the virtual machine. We can use the GPU or any other PCIe device in any VM we want. So, for example, we can create a Windows VM in Proxmox and can pass through an external GPU present like NVIDIA or AMD on the host machine of Proxmox, or we can pass through the integrated graphics to that VM. This will enable hardware accelerated rendering for the desktop or playing games, and you can perform compute tasks like video rendering, 3D modeling, etc. as if you were doing it on a physical machine. Similarly, in a Linux headless VM, you can use the GPU for tasks like AI object detection like Frigate, or running your self-hosted AI with models like Llama 3 locally on your VM. We can even use devices like PCIe Coral TPU to accelerate AI object detection tasks using TensorFlow in Frigate. So, those of you that don't know, Frigate is an NVR software which records and helps in detecting people in a particular video frame. The Linux kernel of Proxmox host presents the GPU to the VM over the PCIe interface and is almost as performant compared to no virtualization. So now let's come to the requirements for the PCIe pass-through. So for that you will require either an AMD, NVIDIA or an Intel GPU like Arc A380 etc. Also, you can pass through a single GPU to a single VM only at a time unless you are using the Intel iGPU with split pass-through, that is GVT-G technology for Intel's 5th generation to 10th generation CPUs, or you are using the NVIDIA's vGPU, which is only available on professional cards like Quadro. And even if you get this split pass-through working, you will need to have a lot of RAM for the iGPU or GPU VRAM, as VRAM is shared evenly across VMs. So, for example, if you want two VMs running, then you will need to split a 6 GB VRAM GPU into two 3 GB VRAM instances or three 2 GB VRAM instances, which may limit its usability. Now, coming to the prerequisites, you'll need to have the virtualization technology enabled on your machine, and also the IOMMU group should be properly configured. In my earlier video regarding Proxmox install, I have shown how to configure the grub and VFIO modules in the Proxmox config to allow PCIe pass-through. So, you can refer that video to get a better idea about the same. But I'll show it here again. Also, this tutorial applies for the PCIe pass-through also, as both have very similar process. Now let's get started on the GPU pass-through. First of all, make sure that the virtualization technology VT-X or SVM is enabled on your host machine, and VT-X is for Intel and SVM is for AMD machines, and IOMMU, which is VT-D or AMD VI, is also enabled in the BIOS settings. Then you will need to blacklist the GPU drivers from the Proxmox host OS to make sure that the GPU is available for pass-through. If you forget to do this step, then you will get an error while starting the GPU VM. So now we have to edit the grub config file present in the Proxmox by visiting the web UI of the Proxmox and entering the shell, and here editing the grub file. So just type so you have to modify this line, which is grub underscore command line underscore linux underscore default, and you have to modify it to the given one in the GitHub link. So for your machine it would only be written as quiet. So you have to add the IOMMU commands here and modify it like this. In my machine it is already modified, so just add these two lines: AMD underscore IOMMU equals to on and IOMMU equals to pass-through. And if you have an Intel system, just modify this line to Intel underscore IOMMU equals to on and just save it and exit it. And now just update the grub configuration by typing update -grub. So in this way the grub config file is updated, and similarly you have to edit the modules file by adding the VFIO modules. So just edit the file by typing now. In my machine I have already added the required VFIO modules, so just add these 4 modules, and once added just save the file and exit it. And now once saved you have to update the initram file system by typing, so just type this command and click on enter. So now these modules would be updated in the boot config of Proxmox. Now after this is done, just restart your Proxmox host and come back to this step. Now to verify the IOMMU is enabled or not, just type this command. So as you can see here, it is showing AMD-VI is there. So the IOMMU is working properly. Now there is a big caveat that the PCI device which you want to pass through is an IOMMU group shared by other devices like the network cards and the Wi-Fi cards. If that is the case, then if you try to pass through a single device through a VM, then all the devices present in that IOMMU group would be passed through due to security reasons. To overcome this, it is best to find a motherboard that has multiple IOMMU groups to isolate the devices better. But if there is no option, then you can use the PCIe ACS Override patch to make the devices appear in separate IOMMU groups to the host OS. This way, you will be able to pass through different devices to different virtual machines. But do this as a last case scenario only, as it is having a serious security implications. IOMMU groups are like sandboxes for the PCIe devices, so that in case there is a bad acting device, it would not be allowed to access the memory of another PCIe device present in a separate IOMMU group. In our case, we are tricking the host system into believing that each device is in a separate IOMMU group, so it allows to pass through the PCIe device. As you can see here, the PCIe ACS override warning is shown here, so this is also mentioning the same. Now I have to use this in my case, as I am using a PCIe M.2 Coral which is connected to the Wi-Fi card slot, and due to that the LAN and the Wi-Fi slot are sharing the same IOMMU group. So it is causing the issue when I am trying to pass through the Coral TPU to a VM. It is also passing the Ethernet LAN, which is causing the server to go offline. Now understanding this point is very critical, as it has big effect on the working of your system. Thus it is best practice not to use the ACS override patch, but sometimes the situation may require the use of ACS override, as some motherboards have bad IOMMU grouping. So just like the example that I told you, This could be a situation where you are forced to use the PCIe ACS override. So now let's see how to enable the GPU pass-through. First, we'll need to again open the grub configuration file by typing nano/etc/default/grub. And here we have to modify the same grub command line to add a few commands like this. Now check the GitHub link in the description below for the proper command to use on your machine. So there would be a variation of commands in which some of them would be having the PCIe ACS override to enable the IOMMU split grouping. So just choose according to your system. Now also the commands that I have mentioned there are for Intel IOMMU. So if you are using an AMD machine, just change it to AMD_IOMMU equals to 1. So just copy the commands from the GitHub link and paste it here, and you can comment this default line and you can add that one. So after copying the command from the GitHub link and commenting out the default command, just paste the command which is appropriate for your machine. And it should look something like this. And I am using the PCIe ACS Override patch, as I have already mentioned that I am using a Coral M.2 which is causing me issues in IOMMU groups during the pass-through. So I am using the PCIe ACS Override patch and using that command. So just save this and exit it, and again update the grub config. Now, as I mentioned, the Intel iGPU split pass-through or GVT-G pass-through. For that, I have also mentioned the commands in the GitHub link, so you can use that command if you want to pass through a single iGPU to multiple virtual machines. And make sure that you are already using it on a CPU from Intel 5th generation to Intel 10th generation, as it is not compatible with Intel 11th generation and above. Now let me explain the following commands. So IOMMU and Intel pass-through is for device pass-through over PCIe. The PCIe ACS override is for having devices in different IOMMU groups, thus there is no security. So just consider that. Thirdly, we are blocking the Proxmox host from using the GPU or its drivers to free up GPU for our use case. Now just restart your system after updating the grub config. Now after the reboot, run the lspci command and verify the IOMMU groups of the PCIe devices. Now, if the device that you want to use is not in a separate IOMMU group, you have to use the PCIe ACS override patch. So, after the device is isolated in a separate IOMMU group, you can pass through the device through the Proxmox GUI interface to any VM. So, for example, let's take any VM. And there just go to the hardware tab and click on add and select the PCI device option. Now here click on the raw device and click on the device drop down, and under here select the PCIe device which you want to pass through. So as you can see, the devices are in a separate IOMMU group, so they will not interfere with each other. So for example, if I want to pass through a graphic card, then I can see the device and I will just select it. Now just click on the all functions checkbox and click on the PCI Express and make sure that ROM bar is also checked. Then click on add. Now your VM settings should look something like this and the PCI device would be added. Now if your VM was running, just shut it down fully and then start it again. Now once booted into the VM, just run the lspci command again inside the VM and make sure that the device is appearing there also. Now I will show you a demo from a different VM on which I have already passed through the GPU. So as you can see in the hardware tab, I have already passed through a PCI device which is the GPU. As you can see here, this is the GPU I have already passed through. So I will just show you the demo in that VM. Now we will run the lspci command inside this VM to verify the PCIe pass-through. So as you can see here, the GPU is passed through and is visible in the VM. So now this part is done. Now if you had an Intel iGPU or an AMD GPU, the drivers for that would already be in the Linux kernel. But for NVIDIA, you have to install them separately. So to install the NVIDIA drivers for the GPU, you have to search for them. So just type So as you can see here, there are multiple options for the NVIDIA driver. Now we have to choose the server driver in which there is no graphic interface. So just select the version which is the latest and is having the server hyphen. So let's take for example this one. So this is the latest version driver and it is the server package, and it is also having the DKMS, which is the dynamic kernel module support. So if you later on update the kernel or you update the operating system, which is the Ubuntu, then the package would automatically rebuild itself to be compatible for that version. And if you don't choose that, and if you choose the no DKMS option, then there would be incompatibilities later on. So I have installed the NVIDIA headless 550 server option. So if you want to install this package, just copy this name and you can type and then press enter. So it would install the headless driver on your virtual machine. So as I have already installed it, you can see it is mentioning that it is already installed. And once the driver is installed, just type this command and you should be seeing a screenshot something like this. So as you can see, the GPU is detected by the NVIDIA driver and I can see the GPU name, its power consumption, its memory usage, and whether any process is using the GPU or not. So now the GPU drivers are also installed. And if you want any other PCIe devices to pass through, you can also do that in the same way by just replacing the device name instead of the GPU. So now the GPU pass-through is working in the virtual machine, and this was how we can utilize the GPU in a virtual machine. Now we can run any application which we want, like LLMs, or we can do remote compute like remote rendering or something else which we want. So that's all for this video. If you have any comments or suggestions, just comment them down below. Thank you for watching.